Biconditional to Q is nothing but if and only if. If and only if means that is 3 is an odd number if and only if logic is easy. If two triangles are similar, then their corresponding sides are not proportional. That can be written as P conditional to negation. Just by looking to the statement, you can say that it started with if and then. If then means definitely this is a conditional statement. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the proposition, simple proposition, compound proposition, and the connectives, writing the truth table for the connectives like conjunction, disjunction, conditional, biconditional, and the negation. Now, in this session, I am going to take few more problems based on those connectives in the verbal form. Now, let us come to the first concept. Now, let us take a first problem. Given P, 3 is an odd number, Q is a Q, logic is easy. This statement is given. What is given? P, 3 is an odd number, Q, logic is easy. Now, what to do? Write the verbal form for the following proposition. So, we have to write the verbal form for all these propositions. First one, P disjunction Q. Disjunction, you know, disjunction means R over R. So, let us connect these two statements using the connective R. Disjunction means R. P, V, Q is nothing but P, R, Q. Now, what is that? 3 is an odd number or logic is easy. P disjunction Q is nothing but 3 is an odd number or logic is easy. Now, the second one, what is second? P conjunction negation of Q. P conjunction Q means, P conjunction means P and Q. Okay. And here negation of Q means not Q. So, that is P conjunction negation Q means P same. 3 is an odd number as it is and negation of Q. And logic is not easy and logic is not easier. So, that is P conjunction negation Q is nothing but P conjunction negation Q is 3 is odd number, 3 is odd number and logic is not easy. Logic is not easy. We are going to connect the connective using and. Conjunction. So, P conjunction Q here. 3 is an odd number and logic is not easy. Now, the next one is Q conjunction P. Again, conjunction means and. First Q. First Q means logic is easy and 3 is an odd number. Logic is easy and 3 is an odd number, that is Q conjunction P. Now, let us come to the conditional statement, P conditional to Q. You know what is the conditional statement? If, then Q. For conditional, if, then Q. That means, now let us write, if 3 is an odd number, then logic is easy. If, then, that is conditional statement is, if 3 is an odd number, then logic is easy. If, then, if 3 is an odd number, then logic is easy. And the next one is P biconditional to Q. What is P biconditional to Q? Biconditional to Q is nothing but if and only if. If and only if means, that is 3 is an odd number if and only if logic is easy. 3 is an odd number if and only if logic is easy. And the last, what is the last? Negation of P disjunction Q. Negation of P. Negation of P is, that is 3 is not an odd number or logic is easy. This is how we are going to write the verbal statement for the given compound propositions. See here. So, first one is the disjunction. Next, conjunction of negation Q, conjunction of Q and P, conditional of P and Q, biconditional of P and Q, negation of P, disjunction Q. So, for disjunction of P and Q is 3 is an odd number or logic is easy. For conjunction, P conjunction negation Q means P conjunction. What is P? 3 is an odd number and logic is not easy. For Q conjunction P, logic is easy and 3 is an odd number. Next, P conditional to Q means if then, if 3 is an odd number, then logic is easy. Next, P biconditional to Q means if and only if, that is 3 is an odd number if and only if logic is easy. Next, negation of P disjunction Q. Negation of P disjunction Q means 3 is not an odd number or logic is easy. This is how we are going to write the verbal statement for the given proposition. Let us come to the next problem. Let us come to the problem number 2. Second example. What is this? Symbolize the following propositions. Here the verbal statement are given. We have to put this in the symbolic form. So first one, 2 plus 5 is equal to 6 are all integers or rationals. 2, what is P? Here P is nothing but 2 plus 5 is equal to 6. What is Q? All integers are rationals. All integers are rational. Then the given proposition is P or Q. P or Q is nothing but P disjunction Q. P disjunction Q. That is 2 plus 5 is equal to 6 or all integers or rationals is nothing but P disjunction Q. That is P disjunction P or Q. Second one, if two triangles are similar, then their corresponding sides are not proportional. So let us consider this as P. Two triangles are similar. What is Q? Their corresponding sides are not proportional. So here the statement started with if then. So what is this if then? If then is nothing but the conditional statement. P conditional to Q. Now here P conditional to Q. What is P? Two triangles are similar. What is Q? Their corresponding sides are not proportional. Here their corresponding sides are not proportional. How to write this? The given proposition is P conditional to negation of Q. Since we have taken not is nothing but the negation of Q. So therefore P conditional to negation Q is nothing but if two triangles are similar, then their corresponding sides are not proportional. That can be written as P conditional to negation Q. Okay. Now let us come to the next set of problem. Next problem, same. Let us take one more example. Symbolize the following proposition. What is given? 3x is equal to 9 and x is less than 7. So what is 3x is equal to 9 is nothing but P. P is 3x is equal to 9. What is Q? X is less than 7 and is connected using the connective that is called conjunction. So and is nothing but the conjunction. So given symbol is P conjunction Q. That means 3x is equal to 9 and x is less than 7. This is conjunction. Second one, if two numbers are equal, then their squares are not equal. If two numbers are equal, then their squares are not equal. What is this? If and then is given. Therefore, this is nothing but a conditional statement. P conditional to Q. That's it. So, two numbers are equal, then the squares are equal. So, that is, if two numbers are equal, then the squares are equal. Here, since it is not is taken, therefore, the conditional statement becomes P conditional to negation of Q. The given symbolic representation for this is P conditional to negation Q. That means two numbers are equal. If two numbers are equal, then the squares are not equal. The squares are not equal. The squares are not equal. That's it. Right. Now, let us come to the next problem. Next one. My friends are coming and we go to a picnic if and only if the weather is fine. Very important problem it is. My friends are coming and we go to a picnic if and only if weather is fine. Let us consider this as P. My friends are coming. Then we go to a picnic. This is Q. If and only if the weather is fine. This is R. There are three statements. My friends are coming. We go to a picnic. The weather is fine. Here how to write the given proposition can be written as my friends are coming. Friends, my friends are coming. My friends are coming and means conjunction. We go to a picnic if and only if the weather is fine means this is nothing but biconditional for R. P conjunction Q biconditional to R. P conjunction Q biconditional to R. That is my friends are coming, and we go to a picnic if and only if the weather is fine. That is P conjunction Q biconditional to R. That's it. Okay. My friends are coming and we go to a picnic if and only if the weather is fine means P conjunction Q biconditional to R. Let us take one more example. If two triangles are similar, then their corresponding sides are not proportional. If two triangles are similar, then their corresponding sides are not proportional. So, just by looking to the statement, you can say that it started with if and then. If then means definitely this is a conditional statement. First point, it is a conditional statement. If two triangles are similar means two triangles are similar is P. Then their corresponding sides are not proportional. Their corresponding sides are not proportional. So their corresponding sides are proportional. Hence here they have taken not. Therefore the conditional the statement can be written as the symbolic representation for the given compound proposition is P conditional to negation of Q. Negation means not. So therefore here if two triangles are similar, then their corresponding sides are not proportional. That is P conditional to negation of Q. That's it. P conditional to negation Q. Very simple. See, they are started with if then. If then means first condition is P conditional to Q. And here there is one more connective, that is not. So therefore P conditional to negation Q is the symbolic way of representing the given compound statement, that is the verbal statement into symbolic form. Now let us take a next problem. If a quadrilateral is a square, then it is a rectangle. Here also it started with if then. So therefore this is also a conditional statement. Quadrilateral is a square, quadrilateral is a rectangle, it is a rectangle. Therefore we can write P conditional to Q. That's it. If a quadrilateral is a square, then it is a rectangle, means P conditional to Q. That's it. Right. Now let us come to the next one. Now next set of problems. Now what is the problem? If the truth values of the proposition P, Q, R are T, T and F, these are the truth values. So the truth value for P, Q and R are given to be, what is the truth value of P? P is T, Q is T, and for R it is F. The truth values of P, Q, R are T, T and F respectively. Then the truth value for the following compound proposition, just we have to write. So solving this type of problems are very, very important. So you may get 7 or 8 marks questions. So based on construction of the truth table. Now let me know how to construct the truth table. So here the splitting of this is very important. What is this contains? P. First write down P, Q, R, then Q conjunction R. Conjunction between Q and R, then conditional between P and Q conjunction R. Conditional between P and Q conjunction R. So first P, Q, R, then Q conjunction R, then the conditional between P and Q conjunction R. So what is given? P is true, Q is also true, and R is equal to F. Write down what is given here. P is nothing but T and Q is also T. What is R? R is equal to F. Now what is Q conjunction R? Q conjunction R means, so here Q conjunction R, what is Q? Q is true, T conjunction F, conjunction and. So in conjunction, if it is true and true, then only true. In other cases it is false. So true and false is equal to false. So this is equal to false, right? In conjunction, true and true is true. In all cases it is false. So therefore true and false is equal to false. Now then conditional between these two, conditional between P and Q conjunction R, the conditional statement, conditional between 2, conditional to F. So in case of conditional statement, true and false is false. In all cases it is true. So true and F is equal to F itself. So therefore the given compound proposition is false. This is equal to false. That's it. See here, Q conjunction R, Q and R conjunction, true and false is equal to, for conjunction of true and true is true. In all cases it is false. So therefore it is false. Again, the conditional statement between P and Q conjunction are true and false. The conditional between true and false is false. So, true and false is false. In all other cases, it is true. So, therefore, this compound proposition is false. Next, let us come to the second problem. Now, what is given second one? P disjunction or conjunction Q. Same, right? P, Q, R, then P disjunction or, then P disjunction or conjunction Q. Right? Now, what is P, Q and R? P is nothing but the truth value for P, Q, R are given. This is T given, this is T given, this is F given. Right? T, T and F. Now, P disjunction R, P disjunction R, P disjunction R is nothing but what is P? True disjunction R. That is nothing but R. What is R? R is nothing but what is R? F. So, the disjunction of true and false. See, in case of disjunction, false and false is false. In all cases, it is true. So, therefore, this is true. This is true. So, the disjunction of true and false is true. Now, what is to write? The conjunction between these two. Conjunction of P disjunction or conjunction Q. So, in between these two, we are going to write the conjunction. So, conjunction of 2 and 2 is true. Conjunction of 2 and 2 is true. So, therefore, the given statement is true. That's it. This is how we are going to write the truth table for the following proposition. Okay. Hope you followed. Right. Now, let us come to the next problem. Next type of problem. This is also a very important problem for 5 marks. If negation P disjunction Q conjunction negation R is a false proposition. So, what is given here? Given negation of P disjunction Q conjunction negation R is false. This is given false. Then find the truth values of P, Q and R. So, if this is false, then find out the truth value for this. Right. Now, if you want, you can find out the one method is just write down the truth table for this P, Q, then negation of P disjunction Q, again conjunction negation of R, just find out where it is false, then you will get the value of P, Q, R, the truth values for P, Q, R. Or the very easiest method is without drawing the truth table, without writing the truth table, we can solve like this. So, what is to find? So, negation of P disjunction Q conjunction negation of R is false, That means this is false. That is and here it is and means, so conjunction is false means either that is negation of P disjunction Q is false, this is false, and negation of R is also false. Negation of R is also false. That means if these two false and false is false, false and false is false. That is negation of P disjunction Q is false, this is false, and negation of R is also false. So, here if negation of P disjunction Q is false means negation of P disjunction Q is false means negation of P is false and Q is also false. That is false and false is false. Right. So, because in disjunction false and false is false, in all cases it is true. In disjunction F and F is F, false and false is false, in all cases it is true. So, therefore, if negation of P is false and Q is also false, then only this becomes false. So, and negation of R is false means R. If negation of R is false means then R is equal to true. Negation of R is false means then the value of R is true. It is true. So, negation of P is false, Q is false and R is true means negation of P. If negation of P is false, if the negation of P is false means definitely P is equal to true, because if P is true then the negation of P is false. So, therefore, if negation of P is false means P is true, Q is false and R is true. So, therefore, the truth values are for P, Q are the truth values. The truth values for P, Q are P is T, Q is false and R is true. So, the truth values are T, F and T. This is how we are going to write the truth values for P, Q and R. Right. Now, let us come to the next problem. If P, Q and R are propositions with the truth values F, T and F respectively, then find the truth value for the following compound propositions. Here, what is the problem given? The truth values are P, Q, R. The truth values for P. For P it is F, for Q it is T, for R it is F. F, T, F. The truth values are F, T, F for P, Q and R. Now what is to find? Then find the truth value for the compound proposition. So first one, P conjunction negation Q conditional to R. What is P? P is nothing but F conjunction negation of Q. Negation of Q is negation of T is F conditional to R is F. Now what is this equal to? F conjunction F. Conjunction of F and F is F. So in case of conjunction, true and true is true. In all cases it is false. So this is F conditional to F. Now what is the conditional? In case of true and F, true and false is false. In all cases it is true. So false and false is equal to true. So therefore the given statement is true. So P conjunction negation Q conditional to R is true. See here, see P conjunction, P is given, that is nothing but F, false, conjunction negation of Q is negation of T, conditional to R is F, F conjunction negation of true is false, conditional to F, conjunction of false and false is false, conditional to R, conditional of F and F is true, because true and false is false. In all cases it is true. Now let us come to the second problem. P conditional to Q conditional to R. P, what is P? P is nothing but false, false, conditional to Q, Q is true, conditional to F. So here true and false. Here just I will write here, P conditional to Q conditional to R. What is P? The truth value of for P is F conditional to Q. What is Q? True, conditional to R is F. So this implies F conditional to, what is the conditional statement for true and F? True and F is F. So again false and false is equal to true. False and false is equal to true. So F conditional to true conditional to F. T and F. T and F is F in case of conditional. F and F is equal to T in case of conditional. This is how we are going to write the truth table for the given problem. Or otherwise, if you want, you can split and write like this, or you can also write like this if you want, or the easiest method is you can write like this. What is given here? So P, Q, R, then negation of R, negation of Q, negation Q, then P conjunction negation of Q, then conditional, that is P conjunction negation Q conditional to R. So this is, you can write here. Okay, what is P? P is F, Q is equal to T, R is equal to F. Negation of Q, it is false. Now P conjunction negation of Q. P conjunction negation, false and false is equal to false. Again the conditional statement for these two, F and R. False and false is equal to true. False and false is equal to true. That's it. This is how we are going to get the truth value. So if you want, you can solve like this also. Any method you can follow to solve this. Okay. Now let us come to the next one. Negation. Negate the propositions. Now negate the following proposition. Cow is big and it is black. Very simple type problem for 2 marks or 3 marks. Now what is the statement given? Cow is big and it is black. This is P. P, cow is big and it is black is nothing but cow is black. Given proposition is P conjunction to Q. Right. So we know that negation of P conjunction to Q is negation of P disjunction negation Q. P conjunction to Q, negation of P conjunction to Q is equal to negation of P disjunction negation of Q. Therefore, negation for the given statement is cow is not big or it is not black. Cow is not big or it is not black is the negative for the given proposition. Usually cow is big means cow is not black, it is not black, it is black means it is not black. So since negation of P conjunction Q can be written as negation of P or negation of Q. So therefore, coffee is not big or it is not black. Let me take one more example. Negate the proposition if the number is real, then it is either rational or irrational. If a number is real, then it is either rational or irrational. So the given statement is conditional. If then means it is a conditional statement. So the number is real. Let us take this as P. The number is real. What is Q? Q is nothing but the number is rational. If P then is either or irrational. Irrational means the number is irrational. So there are three statements. The number is real, the number is rational, then the number is irrational. If the number is real, then it is either rational or irrational. Now, what is the statement given? The statement given is conditional of the proposition is P conditional to Q disjunction or, because we have used or here. So first if then, that is P conditional to Q disjunction or, that is negation of P conditional to Q disjunction or can be written as negation of P is P conjunction negation of Q conjunction negation or. This is the negative of the given statement, that is negation of P conditional to Q disjunction or can be written as, this is logically equivalent to P conjunction negation of Q conjunction negation of R. P conjunction negation of Q conjunction negation of R. Now write down this. The negation of the statement is a number is real and it is not rational and not irrational. A number is real and it is not rational and it is not irrational. Or we can also quote like this: a number is real but it is neither rational nor irrational. This is the negative of the statement, that is a number is real and it is not rational and it is not irrational. This is the negative for the given statement. Now let us take one more example. Let us discuss one more example. Negate: if he is rich, then he is happy. This is P. If he is rich, then he is happy. He is rich is P. He is happy is Q. He is rich, he is happy. This is P and Q. Now, what is the conditions? If then, again, if then means it's a conditional statement. You know, the negation of P conditional to Q is nothing but, what is that equal to? P conjunction negation of Q. That is P conjunction negation Q. That is negation of P conditional to Q is P conjunction negation Q. So therefore we can get he is rich and not happy. He is not happy. The negation of this is he is rich. He is rich and he is not happy. He is rich and not happy. This is how we are going to write the negation for the given statement. That's it. So these are all the properties. Negation of P conditional to Q is nothing but P conjunction negation Q. That is we can write he is rich, P is rich and he is not happy. So this is how we are going to write the negative for the given compound propositions. That's all regarding this session. Let us meet with different types of concept in the next session. Thank you very much.